For the first part is introduction. Uranium was discovered in 1789 by Martin Klaproth, a German chemist and named after the planet Uranus. The science of atomic radiation, atomic change, and nuclear fission was developed from 1895 until 1945. From 1939 until 1945, most development focused on atomic bomb. From 1945, attention was given to harnessing this energy in a controlled fashion for another propulsion and for making electricity. From 1956, the prime focus has been on technological evolution of reliable nuclear power plants. Nuclear reaction deals with interactions between nuclei of atoms, including nuclear fission and nuclear fusion. Both of these processes deal with matter and energy. Fission, defined as the process of splitting of a nucleus into two daughter nuclei, leading to energy being released, while fusion is the process of two parent nuclei fused into one daughter nucleus, leading to energy being released. As you can see, this picture is referred to fission reaction. In this reaction, a stray neutron strikes an atom of uranium-235. Then it absorbs the neutron and becomes unstable atom of uranium-236. Then it undergoes the fission reaction. Then it will produce two neutrons plus krypton-92 and barium-142 plus energy. These neutrons can strike other uranium-235 atoms to initiate their fission reaction. As you can see in this picture, there are two heavy hydrogen, which is deuterium and tritium converted to helium and energy being released. The next part is nuclear power plant, which are pressurized water reactor and boiling water reactor. Both of these reactors use enriched uranium as a fuel and water as a coolant and moderator to slow down the neutrons. The pressurized water reactor, or PWR, has water over 300 degrees Celsius under high pressure in its cooling heat transfer circuit and generates steam in secondary circuit. The boiling water reactor, BWR, makes steam directly by boiling water coolant. The steam separated from remaining water in a steam separator's position above the core and passed to the turbine. Then, the steam condense and recycle.
Hi, Assalamualaikum. My name is Nurliana Sofia binti Farid. So, for my part, I will talk about non-renewable energy, which is fossil fuels. What is non-renewable energy? Basically, it's a natural resource where eventually it will run out soon. And it is made out of fossil fuels such as dinosaur bones and old plants from millions of years ago that were found on the ground. And 95% of the world's energy was used up, but sadly it can only be used once. So one of the examples that we will discuss are coal, petroleum, and natural gas. Fossil fuels are made out of dead plants and animals from millions of years ago. They can be found underground because they are buried more deeper and deeper, layer by layer, by mud and dirt, which when you get more deeper, like if you're in a pool, if you get deeper, the pressure increases, right? So same as in this case where the fossils get deeper and deeper into the earth, where there are massive heat and pressure, which make them turn into carbon-rich deposits. We need to know about coal, that they are made out of carbon, hydrogen, oxygen, nitrogen, and sulfur. They can be found by mining deep into the ground, and there are 3 different types of main coal that we know, which are called anthracite, bituminous, and lignite. So, how did they form? Like I said, they were made out of fossil fuels. So, dead animals and plants were buried under the ground. So, when they went deeper and deeper into the ground, of course, there will be limited access of air. So, when there's limited access of air, plus with the high temperature and pressure, they will turn into carbon-rich deposits, and then they will be turned into seams, which they are basically like layers of carbons. So when people found seams, they will further compress them into these three types of coal. We can differentiate between these three types of coal between how old they are and the amount of carbon they have. So for anthracite, it is the oldest type of coal that people could find, where it has the most carbon content and gives higher energy to produce power. For bituminous, it is medium, so people use it to make steel and cement. For lignite, it has the lowest amount of carbon, yet it is the youngest, so people don't have to dig in really deep to find lignite. So it is used for fuel and steam electric power generation. So same goes for oil and gas, where people found these things by drilling under the ground and they pack it into barrels. So for oil and gas, they were made out of diatoms, where they are actually really tiny creatures that lives under the sea millions of years ago. They can store energy from light. So basically, the carbon from the diatom, they have turned into oil because of the high temperature and pressure, because they've been buried under the sea, right? So when they bury under the sea, under the ground, under the mud and everything, the energy could not escape. So the carbon has turned into crude oil and natural gas. So nowadays, crude oil can be used as many things, and they differ with different aspects such as in color, composition, and consistency. Crude oil has different types and they can be classified as light, heavy, sweet, or sour. The distillation process occurs in the tower, where lighter components will be at the top while the heavier components will be at the bottom. So each segment has their own temperature, where each could produce different types of materials. From the top to the bottom, the chain of carbons are getting longer as the temperature increases. So some of the examples are petrol, fuel, diesel, naphthalene. Lastly, for natural gas, it is made out of methane and it is really flammable, where people found it underground and it could help turbines to produce electricity, and it is also an energy source for water heaters and stoves, and it also can be used for vehicles, and people say that it is much more cleaner because it produces less carbon dioxide. So naturally it has no smell, but it will smell like a rotten egg when there's a mixture of mercaptan.
Wabarakatuh. My name is Norashida binti Muhammad Razali. Today I would like to present chapter 2, which is renewable energy. Renewable energy defined as the energy that comes from resources which are naturally replenished on the human time scale. Renewable energy resource exist over wide geographical area in contrast to other energy sources which are concentrated in the limited number of countries. The use of renewable source of energy. For the heat, it is for biomass energy, solar energy, and geothermal energy. For the electricity, is all the energy. For the physical fuel, it is for biomass energy.
Solar energy. Radiant light and heat from the sun is harnessed using technologies such as solar heating, solar photovoltaic, solar thermal electricity, solar architecture, and artificial photosynthesis. Solar technologies can be divided into two, which is first basis solar, include orienting a building to the sun, selecting material with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. And second, active solar, which is PV panels and solar thermal collectors. Next is solar power. the conversion of sunlight into electricity, and this conversion is either directly using PV or indirectly using CSP, concentrated solar power. The difference between PV and CSP: PV convert light into electric current using the photoelectric effect, while CSP, this system uses lenses or mirrors and tracking system to focus a large area of sunlight into a small beam. Next is solar constant. It is the rate at which energy reaches the Earth's surface from the sun. It includes all the types of solar radiation and not just the visible light. And the value of the constant is approximately 1.366. And next is the energy loss by absorption and reflection. Scattering, absorption, and reflection are the atmospheric processes that can modify the solar radiation when it passing through our atmosphere, and only two can cause energy loss to the incoming solar radiation, which are atmospheric absorption and atmospheric reflection. In this process, sunlight is absorbed by an atmospheric particle, transferred into heat energy, and then converted into long-wave radiation emissions that come from the particle. This emission of radiation is in all directions, so a sizable proportion of this energy is lost to space. Reflection is a process where sunlight is redirected by 180 degrees after it strikes an atmospheric particle. This redirection causes a 100% loss of the insolation. Most of the reflection in our atmosphere occurs in clouds when light is intercepted by particles of liquid and frozen water. So first we learn about latitude. It is a measure of the distance you are located from the equator. It is commonly shown as an imaginary horizontal line that goes across the earth on maps, and it is used along with longitude as a reference point to the determined location, and it is an important factor in determining what type of climate location you will have. And next is the tilt of the Earth axis. It is influence the weather on Earth. The Earth axis of rotation is tilted about 3.5 degrees compared to the plane of the Earth orbit around the Sun, and the Earth field is responsible for the seasons in the world.
Photovoltaics is a method of generating electrical power by converting solar radiation into direct current electricity using semiconductors that exhibit the photovoltaic effect. A photovoltaic system is an arrangement of components designed to supply usable electric power for a variety of purposes, using the sun as a power source. There are two types of PV systems: standalone system and grid-connected system. Standalone system or off-grid system is an independent from electric supply. It provides electricity during power cuts and uses batteries to store power. Meanwhile, grid-connected system depend completely on electric supply. It does not provide backups during power cuts, and it uses inverters as backup. The advantages of using a grid-connected PV system is that it will reduce the power bills, as it is possible to sell surplus electricity produced to the local electricity supplier. Besides, it is also easy to install as they do not require a battery system. It is also effective utilization of generated power because there are no storage losses involved. Solar thermal energy is harvested using a panel to absorb the sun's rays, which are used to warm a fluid or in some cases the air. The fluid can simply be water or in areas at risk of freezing temperatures, a glycol mixture similar to that used in car radiators. The warmed water is circulated usually by a controller and generally through a heat exchanger. It can be used as a part of heating or hot water system. There are three types of solar thermal collectors. Low temperature collectors are flat plates generally used to heat swimming pools. Medium temperature collectors are also usually flat plates but are used for heating water or air for residential and commercial use. Meanwhile, high temperature collectors concentrate sunlight using mirrors or lenses and are generally used for fulfilling heat requirements up to 300 degrees Celsius.
Wind energy. Wind power is the conversion of wind energy into the useful form of energy, such as using wind turbine to make electrical power, windmills for mechanical power, wind pumps for water pumping or drainage, or sail to propel ship. The terms wind energy or wind power describe the process by which the wind is used to generate mechanical power or electricity. This mechanical power can be used for specific tasks such as greening grain or pumping water. A generator can convert this mechanical power into the electricity to power homes, business, schools, and lights. This is the example of item. How loud is the wind turbine? For example, for the 400 meter from the wind turbine, the sound is 400 decibel, which is the same like refrigerator, and the wind turbine in the residential area are placed not close than 300 meter from the nearest house. Wind turbine, like the aircraft propeller blade, turn in the moving air and power of electric generator that supplies at an electric current. Simply state, a wind turbine is the opposite of a fan. Instead of using electricity to make wind like a fan, wind turbine use wind to make electricity. The wind turns the blade which spin a shaft which connect to the generator and make electricity. There are two types of the wind turbine, which is the horizontal axis and the vertical axis. The horizontal axis is like the traditional farm windmills used for the pumping water. The vertical axis design is like the egg-beater style Darius model, named after its French inventor. The most large modern wind turbines are the horizontal axis turbine. For the vertical axis turbine, the blades spin parallel to the ground so that they can operate anywhere regardless the wind directions. For the vertical axis turbine, the axis of rotation is parallel to the ground. The blades are faced in the direction of the wind and spin around a horizontal axis when pushed by the wind. Thus, the turbine can convert the wind's kinetic energy into the electrical energy. This is the advantage and disadvantage of the wind turbine. For the advantage of the wind turbine, which is the clean source of energy, unlimited supply, popular with the public, and use the modern technology. This is the disadvantage of the wind turbine, which is very expensive to install and connect to the power grid, while reliability, threat to wildlife, noise, and visual pollution.
My name is Nurin Atika binti Amir Shahid, and I will continue on the importance of renewable energy. So the first one is the benefit to the environment. Renewable energy are clean sources that will have no chemical waste produced that can harm the environment, unlike non-renewable energy such as fossil fuel that will harm the environment by polluting the air when it is burned. This is why renewable energy will have less impact on the environment. So the second one is a long-last energy. Renewable energy will never run out since it is the source from the nature, while other sources like non-renewable energy may be depleted or decreases over time. Since renewable energy is the source from nature, it means that the source is free and the energy investment can be spent on the materials and workmanship to build and maintain the facilities. Not only that, the renewable energy technology also can be sold to the overseas, as our nation has increased its dependence on foreign oil supplies, so renewable energy will provide a security to our energy. the last subtopic, which is hydropower or hydro energy. So hydro, or other name is water, has been one of the main sources of power for 500 years and more. So now I will be talking about how water is generated. So the first one is we need a water flow. So natural water flows such as river are being used to produce energy. So the faster the water flow, the more electric will be produced. Flowing water will move into to a turbine. Energy produced by the water will turn in the turbine blade, and the turbine will produce a kinetic energy that will be transferred next to the generator. At the generator, the turbine is connected, so the generator can convert the kinetic energy into electric energy. The generator then sends power into batteries and converters in order to send the power out, or the power can be stored. So this is an example of a dam. So when the water from the dam is higher and more confined the space that the water will flow, it will be resulting of the increasing flow rate of the water. The effect is the turbine will be turning faster and more energy will be produced. Now we will be moving to the advantage and disadvantages of hydropower. So for the advantages, hydropower will continuously available on demand as the water will never run out. The second one is it is a concentrated energy if it is given a specific location and a good location. The third one, energy availability can be predicted. So we can predict the flow rate of the water and we can predict the amount of energy that can be produced. Hydropower is a long-lasting technology which even a system of technology can be last for 50 years without major new investment. For the disadvantages of hydropower, the first one is hydropower need a site-specific technology, which is it needs a good location of water power and also location of the supply power. So for the second one is there is always a maximum useful powers output available from a given hydropower site. For the third one, river flow often vary considerably of the season, especially the reason when monsoon type climates, then there is a limit of the energy that can be produced. And lastly, there is a lack of familiarity with the technology and how to apply the power. Now this is how water is converted to power. So first we need two key points that we need to know for the power of the water. First is the flow of the water and the second one is the available heat. So first, the flow of water, which is represented by the symbol Q, is normally given in unit meter cube per second or liter per second, while the head is the vertical difference in level in unit meter when the water falls down. P equal to Q times H times C, where C is a constant, which is the density of the water times by gravitational force. So we will be given a new formula, which is P equal to Q times H times by 9.8 times by 1000. This is how we'll calculate the power of the water. As the efficiency of the turbine is less than 1, then the output power will be the efficiency of the turbine over 1 times by the water power. So there is two types of water turbine, which is reaction turbine and impulse turbine. This is the difference between reaction versus impulse turbine. For impulse turbine, the nozzle for the water flow is fixed at a specific spot that will cause reaction to the turbine. While for reaction turbine, the water will flow to the whole mechanism, which will cause the turbine to move faster. This is why the reaction turbine will produce a larger energy than impulse turbine. My name is Nurul Atika binti Amir Shahid, and I will continue on the importance of